Welcome back to another STEM with Miss Dubois video. In today's video, we are discussing simple machines. So, this is what today's video will cover. Obviously, it looks quite a lot. So, for that reason, each of these videos will be segmented below in like that YouTube timeline thing, or they will be their own videos in case you want to watch a specific part, and all of those videos will be linked below. What is a simple machine? A simple machine is something that makes the amount of work something or someone does easier. And there are 6 types of simple machines. There is the inclined plane, the wedge, the screw, the lever, the pulley, and the wheel and axle. But before we get any further into the video, let's focus on this bolded word, work. And that is because it is a key part in understanding simple machines and why we have them. So, what is work? Work is how much energy it takes to move an object. And there's an equation for it, which is work equals force times distance. But this is a complicated equation, so let's break it down. Work is measured in joules. Joules is the unit for measuring energy. And joules can do this because work is the act of moving energy from one object to another. Basically, you're measuring another idea of energy. Force is a push or pull on an object, and it's measured in newtons. Distance is how far an object moves, and it's measured in meters. Now that we've broken down the work equation, let's rephrase the definition of work. Work is how much effort it takes to move something. Effort is the energy, which is shown in joules, and work is measured in joules. Moving something requires a push or a pull, no matter how you do it. And that is the definition of force. How far something moves is the distance. What is an inclined plane? An inclined plane is basically a ramp, and the goal of an inclined plane is to bring objects to higher positions. Examples include ramps, escalators, and staircases. And now remember, inclined planes do make things easier because imagine carrying something up a ladder that is all vertical. That could not be me. So, I'll take inclined planes any day. A wedge is something that splits things or holds things together. It's basically an inclined plane that moves. Examples of wedges include axes, knives, cruises, or ships. And as for something where a wedge holds things together, an example of that is a doorstop. A screw is an inclined plane that is literally wrapped around a cylinder. Its main functions is to dig holes, hold things together, or lift things. Examples of screws include a screw, an auger that is used for like digging holes, drill bits, a jet engine, and a spiral staircase. Now it's time to move to a lever, which is a rod that rotates around one point. That one point is known as the fulcrum, and the fulcrum does not move. The purpose of levers is primarily to lift things, like that's its biggest function. But there are levers that cut things or open things. And even when we think about opening things, like a lever opening things, it's technically lifting that thing up just by creating an opening between whatever that object was on and the object itself. A lever's primary function is to mostly lift things though, and I really want to emphasize that. And there are 3 types or classes of levers. There is a first class lever where the fulcrum is in between the load and the effort. The effort is the force that you are applying, and the load is always the object being moved. So think of it like this, because I've mentioned these words quite a bit throughout this video. The load is the object that you're moving, always, because you're loading it on to the simple machine. The effort is the force that you, the person, are putting onto the simple machine. Think of effort as you are putting it in, so you are giving it effort, or you are using effort. Think of load as you are loading it on, like you are piling it on. Now that we have that out the way, in a first class lever, you can see the fulcrum in the middle, and examples of first class levers include seesaws and crowbars. The second class lever is where the load is in between the fulcrum and the effort. So where you pile the stuff on, where you put the machine on, that load is in the middle, and the effort is on the end, and the fulcrum is on the way other end. Examples of second class levers include a stapler and a wheelbarrow. A third class lever is where the effort is between the fulcrum and the load. And as you can see, the fulcrum is on the end and the effort is in the middle this time around. All right, so let's look at it like this, okay? The fulcrum is the point that the rod turns around, like pivots around basically. The load is the thing that you are trying to move, the whatever it is, right? It could be a baseball. Effort is the work that you are putting in. You are giving that effort. So the effort for a third class lever is in the middle because you are kind of, or whatever force is being applied is going to be in the middle of the fulcrum, the thing that the rod pivots around, and the load, the thing that you want to move, the object that you want to move. You're not moving it yourself, or else you wouldn't be using a simple machine. Does that make sense? I hope it does. Let me know in the comments. Examples of third class levers include tweezers and baseball bats, with the elbows being the fulcrum, the effort being the hands, because that is where you are inputting your force, and the load being the baseball. The reason why elbows are the fulcrum this time around instead of like the effort is because you're using your elbows to rotate when you swing a baseball bat. You're not actually gaining a lot of force from that. It comes mostly from the lower part of your arm and where your hands are. So naturally that is below your elbows. That is why it is the effort. And the load is the baseball because when you swing a baseball bat, you ideally want to hit a baseball very far. I hope that makes sense. So let's talk about pulleys. A pulley is a grooved circular disc that has a rope go around it or slash in that groove kind of. The goal of a pulley is to lift objects over a vertical path. Examples of pulleys include elevators, cranes, and flagpoles. The final simple machine is wheel and axles, and the goal of a wheel and axle is to amplify the force of an object or to increase the distance that the force is being applied. Now, it's really important to note that wheels and axles move together at the same angle. Examples of wheel and axles include doorknobs, screwdrivers, and gears. And that was today's video on simple machines. I'm Stem with Miss Dubois. Thanks for watching. I hope you have a great day and a great life. Bye!